Everyone, Nicholas JMV here. Welcome to Solving Trig Equations when we have a single trig expression. So I'm going to create 5 or 6 videos on solving trig equations because there's a lot going on. Check out my first video kind of on the introduction of solving trig equations. So what do we mean by a single trig equation? Meaning there's only one trig term, okay? And here's what we're going to do. We're going to solve the equation for cosine of x equals root 3 over 2. So I can rewrite this. There's a lot of ways you can do this, okay? So basically, when I write cosine of x equals root 3 over 2, I need that angle, okay? I need to know what angle gives me a x coordinate of root 3 over 2. That's what it's saying. So mathematically, I can just take inverse cosine of both sides, okay? Because I got to solve for x here. And inverse cosine of the right side, root 3 over 2. Now, what that does for me is freeze this up. This just becomes x. That's one of your properties. So I get x equals inverse cosine of root 3 over 2. And so I've got x by itself. Now I got to ask myself, okay, what angles are those? What angles on our unit circle give me root 3 over 2? So I see it here at 30 degrees. There's the x coordinate. And now remember, the x coordinates are only positive on this half. So it's root 3 over 2. And then I look down here at negative root 3 over 2. Or excuse me, I'm pi over 6. And then down here, root 3 over 2 also happens at 11 pi over 6. So what I would tell you is that my solutions here are x equals pi over 6. That's where root 3 over 2 occurs for the x-coordinate for cosine, and 11 pi over 6. Now, I didn't have a domain here. I didn't restrict the domain, so I've opened this up. So these are the solutions, but I need general solutions. So this becomes pi over 6 plus 2 pi n, and we get 11 pi over 6 plus 2 pi n. And the reason being, if I go back to the unit circle here, I can look here and go one time around. There's 2 pi. There's another 2 pi. And I keep ending up in the same spot. So I need the general solution. So n is the number of times you're going to rotate around the unit circle. So there's my general solution. Okay, so that's our first example. All right, so now we'll go on to example number 2. Let's solve the equation 2 sine theta plus root 3 equals 0 on the interval, okay, from 0 to 2 pi. So now they gave me an interval to look for. Okay, so let's go ahead and see what we can do. Let's go ahead and rewrite our equation. So I have 2 sine of theta. So theta here means you could put it in degrees, but we stick with radians. So I get root 3 equals 0. So subtract root 3 from both sides. Okay, and then I get 2 sine theta equals negative root 3. And then I got to solve or get sine or theta by itself. So I got to divide each side by 2. So I'm going to do that. So now I have sine theta equals negative root 3 over 2. So instead of maybe taking the inverses of both sides, now I got to think what angles on the unit circle do I get negative root 3 over 2? Now, sine relates to the y coordinates. Y coordinates on the unit circle are only 0 on the bottom half where the y coordinate 0. So we need negative root 3 over 2. So I'm looking for a y coordinate, and there we go. At 5 pi over 3. The other one is reflected over here, and we notice we have negative root 3 over 2 at 4 pi over 3. So my two solutions, okay, from 0 to 2 pi now are theta is going to equal 4 pi over 3, and theta is going to equal 5 pi over 3. Now, I don't need the plus 2 pi n because it's not general. This is very specific on a given interval, so that's the difference between the first two answers. This, I have two specific answers, okay? All right, here's another one. We're multi-step here. Solve the equation 7 sine theta plus 9 equals negative 2 sine of theta. So let's go ahead and do this example. So we're at 7 sine of theta plus 9 equals negative 2 sine of theta. Just rewrote it. I'm going to add 2 sine theta to both sides because that's common. I move the smaller amount. You don't have to, but I choose to do it that way. I have 9 sine theta plus 9, equals 0. I subtract 9 from both sides. and I get negative 9. Divide each side by 9, I get negative 1. This is where you can take inverse of both sides. You don't have to. Now I can think of what angle. What angle gives me sine of negative 1? That happens right here at 270 degrees. Your y-coordinate, again, we're talking sine, is negative 1. It's the only spot. So theta here is going to equal 3 pi over 2. Okay, and I didn't have a domain restriction, so I'm going to add to that plus the 2 pi times the number of times around the unit circle. Okay, so there's the general solution there. I got one more. Okay, and we've got solve 3 sine of x minus 2 equals 5 sine of x. Notice how I have x's here, so that's usually what they want in radians. So I have 3 sine of x minus 2 equals 5 sine of x minus 1. Okay, I can subtract 3 sine of x from both sides, so I get negative 2 equals 2 sine of x minus 1. Add 1 to both sides, I get negative 1 equals 2 sine of x. Divide by 2 to both sides, I get negative 1/2 equals sine of x. Again, now, what angles? What angles give me a sine of negative 1/2? Again, sine's negative here. The y-coordinate's negative. So we're down here at 7 pi over 6 and at 11 pi over 6. Okay, so we have 7 pi over 6 plus 2 pi n and 11 pi over 6 plus 2 pi n. The general solutions. So if you have any questions or comments about solving trig equations with one term, you can go ahead and leave them below, and we'll see you next time.